Hi Bio4 and welcome to part 5 of urinary. Let's go through these arteries one more time. The artery is irrigating the kidney. So if you have a renal artery that's entering here, the first branch I didn't mention to you is called segmental. I don't really need you to know that. I need you to know the next one, which is between the lobes of the kidney. So it's interlobar. So we have this one here. It goes then to the arcuate, which is this sort of turn. The turn as it makes coming over the pyramids is the arcuate. Then interlobular, not lobar, but interlobular. So let's see that as this branch here that's coming off, tiny, in the cortex of the kidney. And then we go to the afferent arteriole, the glomerulus, and the efferent arteriole. So you'd want there, it's going to feed into the nephron, correct? So after that interlobular, it's going to be the small artery that feeds into the glomerulus and then out of the glomerulus. So this is another way of visualizing the same blood supply. You would have the aorta. It starts up from the aorta, right? That's where the blood is coming from, to the renal artery, to the segmental, the one I briefly showed you now. You don't need to know that one. To between the lobes, interlobar, arcuate as it turns around the pyramid, interlobular as it goes into the cortex, and now it enters the afferent arteriole, which is going to come into the glomerulus, right? Into the ball of yarn. Beyond that, what's going to happen then is after the glomerulus, it's going to exit, E for exit, the afferent arteriole. And then those arteries are going to cover the nephron with peritubular capillaries and vasa recta. So vasa recta are all veins, peritubular capillary can be both, and they are lining the actual nephron. I'll show you a picture. After that, it's going to go backwards into the same names that are now venous, right? It's distributed its oxygen. It's now going to sort of backtrack the interlobular vein, arcuate vein, interlobar vein, renal vein, inferior vena cava, and back to the heart again. So this gives a better idea of the looping, right? Of coming in to the kidney, coming into the nephron, and then where it goes next. And I hope that's clear. This is a better picture of the peritubular capillaries. So if I had shown you the arriving afferent arteriole in the glomerulus, efferent exiting arteriole, where does it go next? Well, next it's going to branch heavily here and surround the nephron. I didn't draw the nephron in here, but you would have proximal convoluted tubule, you would have loop of Henle, and all that would be here behind us. So these capillaries, all these peritubular capillaries are wrapping around. Why? Tell me why. Think about that for a minute while I get my pen. So if I'm going to reabsorb in the nephron some of that fluid that you filtered out, and reabsorbing means you're going to take it away from what was going to be urine and reclaim it back into the blood. Well, if you're going to reclaim it back into the blood, then these little vessels need to be there for you to be able to do that, to reclaim back into it once it leaves the nephron. Okay, so imagine all these capillaries here receiving more of that blood that will then become venous, and then we'll go back into the venous system. Okay, so all this group here are those around the tubules of the nephron capillaries. In order to make urine, you're going to need a couple of processes. The first one we've already mentioned, which is filtration. You're going to filter that blood arriving from the afferent arteriole. So it's going to be under quite high pressure. It's coming into that glomerulus. The glomerulus is going to act as that filter, and then the blood is going to, once that sort of stream has come into the glomerulus, that little river is also going to exit, and it's going to exit through now what we call now the efferent exiting arteriole. So that's filtration. That's all that happens. That fluid is going to land in the Bowman capsule, right? It's filtered. But the problem is that you've filtered way too much. If you have, filtered 60 liters of this fluid, that's too much. So that fluid needs to be recycled. It needs to be brought back into the blood again and out of what was destined to be urine. So that process is called reabsorption. That filtered fluid, we called it filtrate, but that's really not urine yet. It has to be concentrated. So the kidney will then reabsorb, bring it out of the nephron and back into those peritubular capillaries. It will bring back the fluid and any useful substance which may have been filtered. For example, glucose. Glucose could have been filtered into what would have become urine, but we don't want to do that. We want to recycle it and bring it back into the blood. Most of this is with active transport. The kidney does an amazing job of moving ions in the direction that it needs to move them in. So when it comes to this reabsorption, I want to show you different places in which the reabsorption is actually going to happen. So we filtered here, correct? And there's a lot of detail in this slide that I don't need you to be looking at. I just want you to follow along with me on this proximal convoluted tubule. Oh, look, things are leaving. I'm reabsorbing. Excellent. Vitamins, glucose, amino acid. As long as the arrow is leaving here, I'm reabsorbing. I'm removing it, and it's going to fall into those peritubular capillaries. Where else? Let's go down the nephron. Here, oh yeah, look, here. Reabsorption happens in this descending loop. How about reabsorption in the ascending loop? Well, reabsorption of ions happens. Not so much of water, but ions, yes. So I take those back and set them there in the medullary cortex of the kidney. So here, reabsorption too. Ions, no water. As I come up here into the distal convoluted tubule, remember that term? Proximal convoluted, loop of Henle, distal convoluted tubule, collecting duct. So in the distal convoluted, any reabsorption? Oh yeah. Water again? Oh yeah, salts. How about in the collecting duct? Any reabsorption? Oh yeah, reabsorbing water again and reabsorbing urea. So as you see, there is reabsorption of water going on everywhere except for here, and reabsorption of one thing or another everywhere in the nephron. Okay, so we had filtration, we had reabsorption. What's the third one? The third one is secretion. Substances are going to move now from the blood or those peritubular capillaries in the opposite direction, into the filtrate, even though it was never filtered. So this is very important when controlling the pH of blood. So let's go again. What is secretion again? A substance that was never filtered, right, and is still in the blood can actually still move into the filtrate. So if I use my same picture again, secretion would be bringing something in, like, oh, let's look at this arrow. Oh yeah, the secretion here of urea. That wasn't filtered. That was in those vessels here. And I was able to take it from those vessels and bring it into what's going to be the filtrate. So I don't see any here, but oh, I'm seeing some here. It's coming into the filtrate, even though it wasn't in the filtrate to start with. It wasn't filtered from this end, right? I'm just getting rid of it here. So anything that's incoming there. Oh, wow. So here, I have it again. So those are the regions where secretion is happening. So I can actually eliminate something in the urine without it having been filtered, right? I'm going to say that again. You can eliminate something in the urine by placing it in the filtrate, even though it was never really filtered to start with. You kind of, through active transport, transported it in there. Okay, so that was filtration, reabsorption, and secretion. 3 very important steps in the manufacturing of urine. Okay, thanks for listening. I'm going to stop there.